to ask questions. And I want to begin with you, Dr. DeCicco. In your statement, you mentioned once indirect impacts are considered, it turns out biofuels have caused higher CO2 emissions. And I was wondering if you can tell us what some of those indirect causes are producing those indirect impacts.
Sure, Mr. Chairman. The heart of the problem is really three types of indirect issues that result in higher emissions for biofuels. One is the basic fact that all of the biofuel production, statistically speaking, when you look at the volumes, is really based on feedstocks, crops, primarily corn and soybeans, that are harvested from existing land. In fact, Congress, part of the criteria to qualify for a feedstock under the RFS is that, feedstocks that come from existing land. Now, that was essentially a well-intended provision, but just because we remove, say, nearly on a net basis, after counting co-products, about 30% of our corn and the calories in that corn from the food market to make fuel doesn't mean that the country has consumed 30% less calories. I think we know that. It has to get made up somewhere else. So that leads to the next effect of concern, and that's land use change. And that happens both in the United States, and it's been documented by satellite imagery, where cropland has expanded into other lands, particularly grasslands in the north central region, prairie states. When you convert that land, it releases enormous amounts of carbon that was locked up in those lands. And then you have the international commodity market effects, where to compensate for the biofuel demand for starch, for corn grain, and for soybean, you end up having to make that up in international markets, and you have more crops planted on the frontier, resulting in deforestation, amplifying deforestation in the Amazon and other carbon-rich areas that creates an enormous release of CO2. Then finally, the third indirect impact is that, yes, the use of biofuels does displace some petroleum fuels. So you reduce petroleum demand, that's true. That has a slight, marginal depressing effect on the price of petroleum products that then induces greater petroleum product consumption elsewhere. That's been also a well-documented indirect effect that by itself can erase up to half of the alleged CO2 emission benefit of biofuels, but since I believe there's no benefit to begin with, that's just an additional excess emissions.
Thank you. Dr. Gilna, what's the primary difference between conventional biofuels produced primarily from corn and the advanced biofuels from non-food sources that you're researching at Oak Ridge?
Well, the primary difference is its source. As I described earlier, our goal and hopes have been to be able to generate initially biofuels such as ethanol, but moving to beyond that to other fuels, higher order hydrocarbons, from plant sources, again, that do not compete with food and in fact use different non-marginal lands that can not normally be ascribed or used for food production. So for example, we've talked about and published on crops such as switchgrass, rapidly growing trees such as populus, as a new bioenergy feedstock that allows us to generate fuels, initially ethanol, but now more advanced fuels such as isobutanol. We use the term often drop-in fuels. These are fuels that can use the existing infrastructure, the pump structure, and the piping structure. So essentially the directions that we're going is in advanced fuels that use the existing system from non-food crops. Thank you.
Thank you. And then my last question, is I'm almost out of time, is back to you, Dr. DeCicco. You mentioned biofuel policies restricted to basic R&D. Where do you draw the line? How do we make that a bright line boundary?
Sure. I think the type of basic R&D needed here is really on sort of the very fundamental mechanisms related to the manipulation, utilization of organic substances. So again, some of the very fundamental work that Dr. Gilna has himself done for many years, looking at genetic biochemistry related things. So stuff that is really enabling and could be potentially used for multiple purposes. The other really important area of fundamental research in this regard has to do with things that essentially help plants, help natural systems pull CO2 out of the air more rapidly. Because as I mentioned, if there's to be any mitigation effect at all, it doesn't come downstream when you substitute the molecules. It comes upstream by mechanisms that increase the rate at which you pull CO2 out of the air and then do something with it, which need not necessarily mean turning it into fuel. It could just mean sequestering it. So fundamental research essentially helps plants sequester, rebuild soil carbon and things like that. I think some of that work also goes on at Oak Ridge, perhaps in another division. So there are certain really fundamental biological sciences work that is crucially important for many reasons. Personally, I draw the line right after that. I don't think the petroleum industry needs help figuring out how to synthesize fuel molecules. They will figure out how to make fuel molecules out of whatever feedstock is economically possible. That's their core competency. Some of the earliest work on this cellulosic thing, which is over 40 years old, was started by Chevron in the 70s and other oil companies. They've invested in that. I don't think there's a need for a federal investment in an area where the global oil industry has its huge core competency in chemical engineering and related things.
Thank you. And now I recognize